Consider the formation, breaking and strength of hydrogen bond. Predict which of the following mixture will show a positive deviation from Rault's law. Now, to understand this question, we should have the idea about the Rault's law. Okay, Rault's law, which is basically the relation of the partial pressure with its mole fraction. Okay, and the second point that we should understand is the hydrogen bonding, which is basically shown by the fluorine, oxygen and nitrogen like elements which are having the good electronegativity. Okay, and the third thing that is useful to explain this question is the interactions of the molecules. Okay, interactions of molecules. Now when we talk about the interactions, then interaction simply means that suppose we have a component into this beaker, then what kind of the interactions that we can expect into this particular beaker, there will be the AA kind of interactions that we can expect. Now similarly, if we have the B component into this beaker, then what kind of the interactions that we can expect between the molecules, that is the BB kind of interactions. But if we have the third case, like that we have the component A and component B into this mixture, then you will see that there will be the interactions of AB kind of interactions between them. It means that there will be the interactions of the molecules A and interaction of the molecules between A and B. Okay, right? So the idea to solve this question is there can be the two different scenarios. If interactions of AB is stronger than AA and BB kind of interaction, then you can expect that there will be the negative deviation. You can expect the negative deviation, right? But if the case is, if AB interaction is weaker, then AA and BB, okay, so there will be the positive deviation. There will be positive deviation from the Rault's law. Okay, this kind of the thing is you can see in these right side figures. Okay, the A figure is showing the positive deviation. Why the positive deviation? Because these purple colored line are above the green lines. Okay, so that is the positive deviation from the Rault's law. And in the B, you can see that the purple colored line is below the green colored line, that is showing the negative deviation from the negative. This is the positive deviation and this is the negative deviation from the Rault's law, right? So if we take the options, now let's take the option B. Okay, the second option, that is the chloroform and acetone. So whenever we talk about acetone, that means CH3, C double bond O, CH3. Okay, and chloroform is the CHCl3. Okay, 1 chlorine, 2 chlorine and 3 chlorine. Now this is the interaction between the chloroform and the acetone. When we talk about this interaction, then there will be the hydrogen bonding that you can expect between this oxygen and this hydrogen. Okay, so you can say suppose this is the A kind of the molecule and this is the B, so there will be the strong interaction between AB. Okay, a strong interaction between A, B. So if there is a strong interaction between AB, it means that it will be negative deviation from the Rault's law. Okay, negative deviation from the Rault's law. Now the option number third is the nitric acid and water. So nitric acid and water, they also show the hydrogen bonding. Okay, there will be the strong hydrogen bonding that you can expect over there. How? So it is the nitrogen with this oxygen. Okay, so here you can see that this AB interaction is stronger than AA and BB. So if this is stronger, it means that negative deviation from the Rault's law. Okay, negative deviation from the Rault's law. Now the fourth option is the phenol and aniline. So phenol and aniline. So phenol and aniline, let's take its structures. Phenol is the benzene ring OH and aniline is the benzene ring, okay, with NH2. Now here you can expect the hydrogen bonding from this nitrogen and hydrogen. So here is also AB kind of interaction is stronger than AA and BB. So this will also show the negative deviation. But if you take the option number first, that is the methanol and acetone. Okay, so methanol is CH3OH and acetone is the CH3COCH3. Okay, so when you talk about this kind of the system, then remember that if you take the methanol, then there will be the good hydrogen bond and there will be the good hydrogen bonding between the hydroxyl group of the methanol. You know that this is the methanol, so there will be the strong hydrogen bonding between the OH groups of this methanol. But when you mix the ethanol, when you mix the acetone into this methanol, then the story get changed. How? This acetone basically it will disturb the hydrogen bonding. It will disturb the hydrogen bonding. Okay, it will disturb the hydrogen bonding. So basically the acetone disturb the hydrogen bonding and the hydrogen bonding between the methanol is very weak due to the acetone. Okay, and the binding sites will also changes by the acetone. So what you can expect is here you can see that the interaction between the A and B kind of the molecule, this interaction is poor interaction. Okay, this is a weak interaction. This is a weak interaction, and if the interaction is weak, then we know that if the interaction is weak, then there will be the positive deviation from the Rault's law. So here you can see that this is the positive deviation in the Rault's law. Okay, so that's your answer. So option number A is our answer. All right, thank you.